No, definitely persons would have realized that JPS would have been going around and changing out the meters to some to the newer ones that they actually refer to as the smart meter. Now, before smart meter, they had one that was actually known as the digital meter, and before the digital meter, they had one that would have known as the analog meter. So this is the oldest version of meter that JPS would have been using. So this one, it is known as the analog one. So in terms of reading the analog one, that is the old time ones, it would be much more difficult than reading the smart one or the digital one. Because for example, the one that they are using now, that is known as the smart one, in terms of GPS persons going around to read meter, they definitely don't have to do that. Because in terms of the information, that information can be popped up on their system. Now, in terms of in Jamaica, as for the analog one, that is almost completely don't use anymore. So the reason why we're still looking at the analog one is simply because as it relates to CXC, it is not just Jamaica, it is for students right across the Caribbean. So definitely there are other territories or there are other islands where they are using the analog meter same way. So that is why CXC is still having this content in their syllabus in terms of we looking at the analog meter in terms of how to read it. So persons who would have been familiar with this type of meter might be just seeing these small dials that look like clock, and they are trying to figure out how they read it. So definitely that's what we're going to be going through this morning. So the digital one normally comes with numbers. So what you're seeing on the screen now, it is basically saying that this person's would have used 6031 in terms of kilowatt per hours. So that is the reading. That is kilowatt per hour is the measurement, or is the unit that we normally use to measure the amount of electricity that is being used by a customer. So what you're seeing on the screen, you're seeing a digital meter, and the reading is 6031. That is for this reading, or this is the reading that this customer would have been used so far. Because in terms of you getting how much they use per month, what they normally do, the reading that they read now, they would actually subtract or minus the previous reading from the reading that is on the meter now, and the difference is what will tell you how much you burn for that particular month. Because once JPS would have give you electricity, all meters start out at 0. So every time they read the meter, the numbers just get higher and higher because the number just continues to just count like that. So the only way JPS can know how much you use per month is by them minusing the previous reading from the current reading. Because let's say for example JPS install your meter today, or today is the first day you get electricity. Once you start to use it, then the meter now gonna start from 0 in terms of kilowatt. So let's say for example by the end of the month, when JPS look at your meter, they actually see 1000 kilowatt per hour. That simply means that for the first month they give you electricity, you would have burned 1000 kilowatt per hour. So that would be for the first month. When the second month come and they come to read the meter not going to go back to 0. from that 1000, it's just going to continuously getting higher and higher. So let's say, for example, when they come for the next reading, it is 2200. That does not mean that you burn 2200 for the second month. It means that from they would have give you the electricity, you would have burned that. So if for the first month and the meter is showing 1000, and for the second month it is showing 2200, it is simply because the meter don't go back to zero, it just continue getting higher and higher. So OJPS can know how much you burn for that second month is by them minusing or subtracting 1000 from the 2200, and that will give you 1200, and that will be actually the reading for that second month. So that's how the meter work, meaning that the meter just continuously getting higher and higher in terms of numbers. So OJPS know how much you burn for a particular month is by them minusing the previous reading from the present reading, and the difference is what will tell you how much you burn for that particular month. So they are saying that for digital meters, the amount of electricity used can be read directly, and that is simple because you can see it on the screen. As for the analog one now, so analog meter has 5 or 4 dials. So these circles that you're seeing that look like clocks, they actually call them dials. Each dial number 0 to 9. So if you look at each one of them, you're seeing in the middle, it is number 0 to 9. The dial alternately move clockwise and anti-clockwise. Now when you examine them, so look at the first one, you will realize that the numbering start at 0 and go right up to 9 right round. So the first one, actually the numbering go into a clockwise direction. Clockwise meaning that if you have a analog clock on the wall, the same direction in which the number on that clock. That is what you're seeing for the first one. As for the second one, it is anti-clockwise. And that is simply because when you look at it, you're seeing that on the left hand side, that's where the numbering starts. 0, 1, 2, 3, 4, 5, 6, and go up to 9. So that is anti-clockwise. As for the third one, this is clockwise again. So I mean that it is numbered in the same direction in which you would number a clock. And then the fourth one is anti-clockwise. So that's why that third pointer is saying that the dials alternately move clockwise and anti-clockwise. So some meter they are saying it will have 5 dials, so it will have 5 of these circles, which on the screen you are seeing 5, while for others it would be 4. So those small circles, they are known as dials. So that is what you would see on the analog one and the analog meter. As for the digital, there's no dial. The digital one basically just show you exactly what amount you use, meaning that you don't have to go through the long process in terms of learning how to read it. So definitely we're going to look at how JPS, so when I see the persons coming around to read meter back in the days, when this type of meter is what you would have at your premises, you're going to actually know how those JPS persons would have come up with that reading. So in terms of reading now, read the dial on the left. So the one to the extreme left. Once the JPS persons, once they are reading the meter, they start at the one to the extreme left. So that is what that first pointer is saying. As for the left one, the one to the extreme left, this gives the 10,000 digit. The second one now, so the first one, which is the clockwise one, will give you the 10,000 digit. The second one, which is the anti-clockwise, will give you the 1,000 digits. The third one will give you the 100 digits. Fourth give you the tens, and the fifth will give you the ones in terms of digit. Now the value is taken by the number which the hand is directly on or has just passed. So we have an example in terms of a meter. So this one now have 5 dials. So the reading for this meter, so the reading for the meter above is basically 66,482 kilowatt per hour. That is the reading for these 5 dials that you're seeing above. So in order for you to, so when the JPS person come to read this customer meter, 66,482 kilowatt per hour is what they would written, is what they would write in their book for the reading there. So how they arrive at that, we're going to actually start from the one at the extreme left. Now going back to the previous slide, alright, so looking above at the pointer there, because we need to refer to what the pointer is saying above. The value is taken by the number which the hand, so the hand is this black section that you're seeing, because by now persons must know the hand of a clock or a watch. So which the hand is directly on, or it would have just passed. So as for the one to the extreme left, so it is, this one is number in clockwise direction. So one, so that means that the hand is coming from this direction. So as you realize, it would have just passed 6. When you look at the reading they have there, so that would represent the first 6. The second dial now, this one now is anti-clockwise. So the count, so the hand is moving this direction. So it actually starts at 0, go to 1, 2, 3, 4, 5, and it would have just passed 6. And again, remember the pointer above said that the value that you normally write down is where the hand is directly on, or where it would have just passed. So this one passed 6. So that is why we have the second 6 there in terms of value. Now let's move to the third one. So we are looking at the 4 now for the third one. So this one is clockwise. So it starts at 0, 1, 2, 3, 4. So it is, so the hand don't reach 5 as yet. So that simply means that it would have just passed 4. So that's why they have 4 there as the 400. Alright, moving down to the last 2 dial now. So this one now is number anti-clockwise. So in terms of the hand would have been moving this direction from 0, 1, 2, 3, 4, 5, 6, 7, 8. And as you can see, the hand is directly on 8. And that will represent the 8 that you have there. And as for the last one now, which they are saying that is 2, this one is number clockwise direction. So we have 0, 1, 2. So the JPS personnel would have now write down 2 because the hand would have just passed 2. And that is how they will get the 2 there. So as you can see, the 66,482 kilowatt per hour. So as for the older meters that are known as the anti-lag meters, that is how the JPS personnel read the meter. Again, they normally start from the left. Of course, you can start from the right, but it's just because you can't even start from the right. Because if you start from the right, where you're seeing the 2 there, so the only way you can know is by you having the figure. So again, in terms of how they arrive at the 66,482, they start from the left, which will give you where the first dial here, it is clockwise. So you count the direction of the clockwise. So we have 0, 1, 2, 3, 4, 5, 6. So the hand would have just passed 6. Therefore, you have to write down 6. So you can't write down 7 because the hand don't reach 7 as yet. Because the above statement would have said that you write what the volume that the hand is on, or what it would have just passed. So that is how they get the first 6 right there. As for the second 6, this dial, as you can see, it is number in an anti-clockwise direction. So they start at 0, 1, 2, 3, 4, 5, 6, and again the hand would have just passed 6. So the JPS personnel write down 6 right there. Now let's move on to the third dial now. So this one is numbered in a clockwise direction, where you have 0, 1, 2, 3, 4. So the hand, it actually passed 4, and it don't reach 5 as yet. So the fact that it don't reach 5 as yet, the JPS personnel cannot write down 5 in their book. They have to write 4. So as you can see, it is on the 4 right there. Moving down to the fourth dial now. This one is now numbered in an anti-clockwise direction. Therefore, you have to go this direction. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And you can see the hand. The hand is now on 8. So JPS personnel now would write down 8 there. And the final dial, this one is numbered in a clockwise direction. So you have 0, 1, 2. So the hand would have just passed 2. So the JPS personnel write down 2 on the screen. Alright, so I hope that students, you understand how to read it. Hello?
Yes, sir.
Yes, sir.
Yes, sir. Alright, so what is on the screen now, what I want you to do now is make an attempt to read that one that is on the screen now. So within the next minute, I'm gonna, because I have not read it as this, so I'm gonna read it now. So the one that is on the screen, based on how I would have explained how to read it, the one that is on the screen now, see if you can read it and write it down in your book or some form of paper, the reading there. So just 1 minute I'm giving you to do that. Read the one that is on the screen. You can see it clearly. The meter on the screen.
Yes, sir.
Right.
Yes, sir.
Alright, so see if you can read it. Just 1 minute to do that. So remember, you start from the left and you write down the numbers. Alright, so I'm finished. Anybody else finish? So the number that you have, ensure that it have 5 different digits. Alright, so we can start. We can go through it now. Yeah, yes, Campbell. Say, how much I get? 4. You have to get a double. You have to get some 40 something. You have to remember that is 5 different dials you have, you know. So what you write down on your paper, it should be 5 different value, and definitely Anybody else come up with a reading? Now remember, you write down.
49,
How much you get?
49,814.
49,814. Well, you're close. You're close, but so meaning so the last two you would have messed up. The 14, it is not 14. Now remember, you write down the figure where the and would have just passed or where it is on now. So just remember that you're reading some clockwise and you're reading some anti-clockwise. So the first three, you get the first three correct meaning. So it's just the last two dials you don't get correct. That's the last two dials.
Sir,
Yes, Williams?
sir, we got 49,803.
Right, yes. So 49,803. That is the correct one. So we're going to go through it and see that yes, it is actually correct. Because yes, we can make mistake. So again, remember that we use where it would have just passed or the hand that is on. So the first one, it is number in a clockwise direction. So we have 1, 2, 3, 4. So the first one, it is on 4. So in your book or on your piece of paper, you write down 4. The second one, this one is number in a anti-clockwise direction. So we're going to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you realize the hand, it is almost on 0. So that means that it would have passed 9. Because remember that it is counting from 0. So that's why you write down 9. As for the third one, it is in a clockwise direction. And as you can see, it is directly on 8. So you write down the figure 8. As for the fourth one now, this one is number in a anti-clockwise. So you're going to start count 0, 1. So if you realize it is between 0 and 1. So that simply means that it would have passed 0, but it don't reach the 1 as yet. So that's why you write down 0. As for the last one now, it is clockwise. So if you realize 1, 2, 3, 4. So the hand, it would have passed 3. But when you look upon it carefully, you realize that it would have not reached 4. Now, in terms of the figure 4, it look like it is on the figure 4, but remember that in our clock, you actually have some dots or some lines. That is what you normally use to indicate or show that yes, it is actually on that figure. Because when you look at the dial, you will realize that for each number, exactly on the circle, there's a small dot. So the hand have to reach that small dot for you to write down that figure. So that is why it is 49,803 in terms of kilowatt for that reading. Alright, so let's move. So I would have explained that one. So now here we have a setup in terms of how GPS now going to actually know how much you actually burn for a particular month. So they said that meter is usually read every 4 weeks. So that is every month. So how the GPS get to know the amount of electricity used for that particular month. They are saying that it is equal to the second reading minus the first reading. So the first reading, basically what we are seeing now, if you look at the numbers, you're seeing 66,649. That would be the second reading. The first reading, that is the previous slide. So the first reading would have been 66,482. So if JPS want to find out how much electricity this person burned for this month, the reading that they get for January, they would basically minus the reading that they get for December to arrive at that figure. So as for A, that is the top set of dials, we would have already looked at that on the previous slide. which was of course was 66,482. As for the second reading now, as for the second one, they are saying that it is 66,649. So let's look at the dials and see if that is correct. So looking at the first one, so the dial, this it is clockwise, so start from 0 going that direction. The hand would have just passed 6, so that will take care of the first 6 there. And looking at the second dial now, this one is anti-clockwise, and as you realize the hand, it would have just passed 6, so that will take care of the second 6. And looking at the third dial now, this one moving clockwise, so the hand would have just passed 6, so that will take care of the 6 of the third 6 that they have in the reading there. And looking at the fifth one now, going this direction, 1, 2, 3, 4, and the reading there saying 9. But if you realize, would you say that you would question that 4? Would you say that you would have 5 there, or the 4? The fourth one, you realize that it actually close to the 5, 4. All right. Well, yeah, that's a 4, so I would say 4. But I'm quite sure that it is debatable, because why it is debatable is because if you realize for this dial, they don't have the black lines that the meter show a while ago. So I think for future reference, the persons who write this textbook, because this diagram come directly from a textbook, you know. All right. So I think it would have been best for them to use the lines. So like beside 0 and beside 1, they actually put the lines so you can see exactly when it point on that particular number. So then say 4. So let's just say, all right, then it is 4. And as for the last dialogue, this one is clockwise. Say they would 0, 1, 2, 3 go up to 9. So if you realize the hand, it would have passed 9. Hence they actually have the 9 there. So the 66,649, that would be the second reading. And the first reading would have been 66,400, or if you want to say the previous reading, 66,482. So they do the division, the minus, they do the mathematics, and they would have arrived at 167 kilowatt per hour. Now, for somebody who, let's say, for example, that person have like 3 light bulb and 1 radio, 1 TV, and 1 small fridge, then that person would actually burn approximately that amount per month, 167 kilowatt per hour. Because when you look on your light bill, every light bill that you get, you will see that your kilowatt per hour is like 100 and something, or 200 and something, or 300 and something. Like Claude Mackey, you know, their kilowatt per hour per month is like, for example, 3,000 had to the amount of light that turn on and the amount of fridge and different things. But for a normal customer who have, like, for example, a 1 and 2 TV, like 5 bulb in the house, radio, they might use washing machine, then their kilowatt per hour per month is like, for example, anywhere between 150 and 250, go up to 300 thereabout. But we're going to go into detail in terms of looking at an example of a JPS bill. All right, so in terms of calculating the bill, there is a lot of procedure, and that is due to the fact that JPS, for example, charge you for different things. So in terms of you getting a bill, it is not just one thing that they charge you for. They charge you for a lot of things. So we're going to actually go through some of those things that JPS charge you for. So in calculating the bill, the energy used by the customer may be charged at, then can charge a flat rate, so the customer pays the same price for all the kilowatt hours energy used for that month. Energy charge equal energy use, so that is the kilowatt, multiplied by the per hour. So let's say so they are giving you an example there where you have the $46 and equal, so you have the 200 multiplied by 0 by 23 cents. So what this is saying is that for this customer, their kilowatt per hour, if their kilowatt per hour is 200 kilowatt for that month, and JPS charge a flat rate of 23 cent, the JPS just multiply the 23 cent by 200, and that will give you a figure of 46. So they're just giving you an example in terms of the flat rate there. But as for our one, it is much more complicated. Then we have a next type that is known as the block rate. So if I should ask you to give me the type in terms of the rate, the two different types in terms of rate that energy companies normally use, you can say the flat or you can say the block rate. So we're going to spend some time looking at what the block rate is actually, how it's set up. So cost per kilowatt hour varies based on the amount of energy the customer uses. For example, the first 100 kilowatt per hour costs a particular rate. The next 50 kilowatt per hour, another rate. And I'm going to bring up a bill. I'm going to bring up a JPS bill and show you that that's how JPS actually charge us in Jamaica. Just give me a moment to bring it up and share that screen with you. Because JPS don't use flat rate. JPS actually use a method that is known as block rate. So that simply means that they have a cutoff point for the first 100 kilowatt. They will charge you a particular amount, and then going further on, anything above that, they charge you another based on the per kilowatt. All right, JPS. JPS. JPS bill. All right, the screen, you seeing the screen now? You seeing the screen now?
Yes, sir. Yes, sir.
All right, so this is
Yes, sir.
right. So this is my December bill. So this is my December bill. So look if you can see the one that said current reading. You're seeing current reading and previous reading at the top. Look if you're seeing those previous reading and you're seeing
Yes, sir.
current reading. All right. So if you realize the previous reading was 6,187.07, and why JPS have the 0.07 is because remember that the nowadays meter, it is digital, so they're gonna have 0.0 and all and something there. The current reading is definitely more, 6,522.91. So if you realize the minus the 6,187 from the 6,522, and that will give you what you're seeing in yellow there, 335.84. So that is the amount I would have used from November 26 to November 27. Alright, let's scroll down and look at the bill now. How they arrive at that 23,000. So I don't know if you're seeing this section. You're seeing the section where you have the heading, how your bill is calculated.
Yes, sir.
Right, so let me see. I'm gonna zoom it up a bit. Alright, I'm gonna zoom it up so you can See it, right? So the heading, how your bill is calculated. So you have balance brought forward minus 33 $72. That means that the previous one I would have paid $33.72 more than the amount. So that's why I said minus. All right, so energy. Yes, you're seeing energy.
Yes,
All right.
sir. Yes, sir.
Oh, okay. All right. Sorry for that. Oh, it's up, all right. So the reading for energy. Remember that the bill would have shown that I use what 300 and yeah 335.84. Somebody might making a sound. Mute that mic. All right. So for the first, so they say energy first. So then say energy up to 100 kilowatts. So out of the 335, the first 100 kilowatt that I use, they are charging me $7.32. Remember, I use 330 something. So out of that 333, the first 100, they are charging me $7.32. Now if you minus 100 from the 335, that will give you 235. So look at the bill what them say. JPS say energy next for after 100 kilowatt per hour. So anything me burn after the first 100 kilowatt per hour, them are going to charge me $21.03. So you see the next 233, if you realize it is 4,959. So that simply means that they minus, that simply means that they multiply $21.03 by the 233. Because remember, then say for the first 100 out of that 333, them are going to charge me $7.32. So what they would have do, they would have multiplied 100 by $7.32. And if you realize over the unit cost, then said that that's $732. So if, for example, me did only burn 100 kilowatt per hour, my bill would have only be $732. You understand that?
Yes, sir. Yes, sir.
Okay. So for the next, so the fact that my one said that me burn 333 and whatever. The next 200 no, them are gonna multiply by 21 $3. So in terms of the energy costs, in terms of how much they're charging per kilowatt, that is only 6,223. But you see, because JPS charge of all type of sitting, that's why I reached 23,000. So let's look at the other charges where they give you. Here then say they have one something when you fixed adjustment at 6.44%. Fuel charge, because they charge of which fuel, and they don't just charge you a flat rate, they charge you fuel charge per kilowatt. So if you realize the fuel charge, $33 and 1 cent you would have said, if you round off that, it would actually give you 1 cent. So you see, because my bill say me burn 333, what JPS do, they multiply the $33 by 333, and that so comes you have the 11,000 there. So you understand? So
Yes, sir.
right, so all of them fee, them basically multiply it by the kilowatt per hour. See, they have one other charge. I don't know what they say IPP variable charge, which me don't know what IPP mean. So per kilowatt, they say that at $11.27. So you see what JPS do? They multiply that $11.27 by the 333 kilowatt, because they say per kilowatt, and that will give them a figure of 3,784. of course 92 cents. Then say the turf adjustment, I don't know what that is. Then say it is minus, if you round off that, that will just give you 11 cent, and they are saying that minus 37. So I guess on the previous bill they would have overcharged me on that, so that is why you have a minus figure. And then still not finished calculating now. GCT 15% of charges. So if I never have to pay a tax, my bill would have been 21,456. But because if you don't do the maths and find 15% of the 21,000, that will give you $1,855.13. So because that is a tax, because the tax go to government, they will now actually add that to it, and that will give you the 23,000. So going down, they are saying the taxable portion of my bill. So anything above 150 kilowatt per hour, that's what they are actually charging me for tax. So if my bill, if I did only burn, let's say for example 150 kilowatt per hour, then I wouldn't have to pay any tax. What that means is that for persons who don't burn above 150 kilowatt per hour, they don't pay any tax. So they are saying that non-taxable portion of my bill was $9,089.29. So that's how JPS calculate everybody bill. So that section there, so you can look at a bill that you have at home and you will see the similar rate charge in terms of how they actually charge it. So in terms of now why the bill normally fluctuate is because if you realize the fuel charge is the highest. The fuel charge is $33. So what that mean? Whenever you listen to the radio and the TV and you hear them say gas price gone up, you say once the gas price gone up, your bill gonna go up. Because gas is what JPS use to power their turbine to give us electricity. So if the gas price should go down, then we should see some slight, by right, we're supposed to see some slightly deduction in our electricity rate. But trust me, JPS hardly do that. So once the gas prices are continuously go up, then definitely your JPS bill will actually go up, because simply because I use gas. And as you can see, for every kilowatt per hour that I burn, they charge me $33 for that fuel charge. So as for the block rate, so looking at the bill, you would have seen that JPS definitely use a block rate, which the block rate has again said that that method or that formula is that cost per kilowatt per hour varies based on the amount of energy the customer use. For example, the first 100 costs a particular rate, and you would have seen that for my first 100, then charge like $7 and some cent. The next 50, another rate. So anything above 100, they said that they would have charged me, I think, $23 or $21 thereabout. So JPS definitely used the block rate. So if JPS, for example, would have used a flat rate, then would have just charged me one flat rate. So for that 333, they would have just multiplied by one flat figure. But that is not the case. So persons, so like Claude Mackey and big companies, I mean, they pay a lot based on the fact that they would have burned way above 300 and odd. Because like for a school bill, their JPS bill on a monthly basis is like 200 and odd thousand, 300 and odd thousand. And that is simply because of all those charges. Because remember that for the fuel charge, for example, they will multiply that per kilowatt per hour. Alright, so energy consumption for appliance. So we're going to actually look at how it actually relate to a particular appliance. So with this aspect of the lesson. Once you're through, you should be able to actually narrow it down and tell how much electricity a single light bulb is burning, for example. So the energy used by home appliances can be calculated by multiplying the power rating of the appliance by the time period used in hours. So they are saying that so energy use kilowatt per hour will actually equal to the power rating, that is the kilowatts, multiplied by the amount of time that particular appliance would have been plugged in. So we have an example there. All right, yes. So here we have a light bulb. So as for the light bulb, in terms of how much electricity it pulls only 60 watt. So if it pull only 60 watt, that means that it don't reach kilowatt. Because we must say kilowatt, in order for you to have 1 kilowatt in terms of usage or something measured 1 kilowatt, you would have to get it would have to be 1,000. So 1,000 watt is what basically give you 1 kilowatt. So 1,000 watt give you 1 kilowatt. So they do the multiplication. So when they do the multiplication, as for the 60 watt bulb, if it should turn on for 1 hour, the amount of kilowatt in terms of energy that bulb would burn is 0.6 kilowatt per hour. So here they have the same bulb down below. If that 60 watt bulb now should be turned on for 8 hours per day, for that 1 month, it will actually burn 14.4 kilowatt in terms of energy. So you can find out how much electricity that bulb is burning per month. All right, so here we have so this stove now. So calculating the cost of running a stove. So we know these as hot plate. So an electric stove has a power rating of 6,400 watt. If the if the electricity company in the territory charge a flat rate of 0.024 per kilowatt, so this is not JPS, because JPS don't charge flat rate, they use block rate. What would be the energy charge to run the electric stove for 3 days continuously? So remember, they are saying that the rating is 6,400. So, and that is what, and remember that 1000 watt is what will give you 1 kilowatt. So the first thing you have to do, you have to convert the 6400 watt to kilowatt. Divide that by 1000, and that will give you 6.4 kilowatt. So 6.4 kilowatt. So the numbers that you must bear in mind to do this calculation is the 3 days. And remember that 3 days will give you 72 hours. And you have to remember the flat rate that that company charge. So we're going to go down to the next aspect of it. Calculate the energy used by the electric stove. So the time is 3 days. So the first thing you have to do is find out how many hours in the 3 days. So you're going to multiply 3 by 24. So that will give you 72 hours. So right away in the back of your mind, you're supposed to know that the fridge, not the fridge, the stove was turned on continuously for 72 hours. Because remember, the first part of the statement said that it was turned on for 3 days continuously. So you now need to find out how many hours in that 3 days. And we're saying that it is 72 hours. How comes it is 72 hours? It's simply because each day contains 24 hours. So let's go down. So then say energy use. So power multiplied by time. So the power is, again, it is 6. Oh, the screen move. Right, so the power, it is, when you, after you convert it, it is 6.4 kilowatt. So you multiply that by 72. So once you multiply by 72 now, you will get 460.8 kilowatt. So this is the amount of kilowatt that the stove burn for those 3 days. Now you now need to find out the amount that the stove costs. So you're going to multiply the flat rate, because then say the companies charge 0.024 cent, which if you round up that would basically be like 2 cents. So once you multiply that by the 460, which would be the kilowatt per hour, you would get $11.06. So for those 3 days, that particular stove would have cost that customer $11.06 in terms of bill for that particular stove. So every appliance in your house, the longer you keep them turned on, is the more it will cost you in terms of electricity based on their kilowatt per hour. So that is why whenever you're buying bulb, if you realize you have 100 watt bulb, you have 10 watt bulb, you have 30 watt bulb. So if you don't want to pay a lot of electricity, the lower the number in terms of watt that is on that bulb, the better for you. It is just that the higher the watt is, the brighter the bulb would normally be. Because a 100 watt bulb in comparison to a 50 watt bulb, the 100 watt bulb, it will go brighter when you turn on that bulb versus the 50 watt bulb. So the difference between a 100 watt bulb and a 50 watt bulb is that the 100 watt bulb, it is brighter, but it burns more electricity. While the 50 watt bulb, it is duller in terms of the light that it gives off, but it burns less electricity. So here now, so this example now is showing you how to calculate the cost of running a refrigerator. So down there saying that a refrigerator has a power rating of 170 watt. If the electricity company in that territory is charging the same 0.24 kilowatt per hour, calculate the cost of running the refrigerator for 72 hours. Assume that the refrigerator runs continuously for this time. So we get the amount of hour, 72, so we don't have to convert that. But the first thing we have to do, we have to convert the watt to kilowatt. So the rating for that fridge is 170 watt. So you're going to divide it by 1,000, because remember that 1,000 watt is what give you 1 kilowatt. So you will get 0.17 kilowatt.
You're not seeing that slide.
Oh, you're not seeing this one? Let me share and reshare. You're not seeing this. Oh wait, let me share. Stop. All right, check if you're seeing calculating the cost of running a refrigerator. You should be seeing it now, man. Right. You seeing it? You seeing my screen now? You, who not seeing it? Somebody's. Well, you should be. Okay, right. All right. So you do the conversion. Right. So converting the 170 watt to kilowatt, you divide it by the 1,000, so you get 0.17 kilowatt. And remember that we have the 72 hours already. So in order for us to find out how much kilowatt the fridge would burn for that 72 hours, we just simply multiply 72 by 0.17, and that will give we 12.24 kilowatt. So the company charge a flat rate of just 0.24. So you just simply multiply 12 by the 0.24, and in terms of how much, that is just a really small amount of the 29 cent there. So that's how you actually calculate it. So in terms of your stove, your washing machine, your laptop, your phone, and all those things, you can find out, because if you look on your laptop charger, you're supposed to see the power rating. And the power rating on a laptop charger is like zero point 0. So a laptop charger per month, I mean, sometimes maybe I want $3, want $1, or so it actually costs you. Simply because the power rating on those devices, they are extremely low. All right, so in terms of the notes, definitely, yeah, I would have sent it from last week. So after looking at how to read the meter, how to calculate the bill and all of that, um, we should spend some time now looking at wiring, or the tree wiring, because in terms of you getting electricity, then definitely the electricity come through some form of cable. So some form of cable is what it should come through.